Hi everyone, it's Shervin, and I'm the master's student of artificial intelligence and soft computing at American University of Technology. And today I'm going to talk about prompt engineering and large language model fine tuning, finding trade-off between them, and identifying different tips. We're going to introduce some different tips and about how prompt engineering works, how it can help you into expecting a better response from large language models, and in which cases it will be more computational efficient to fine tune. It will be more financially efficient to fine tuning a large language model or using advanced prompting techniques. And first of all, we're going to talk about about basics of prompt engineering, and the second is about we're going to go further on the prompting techniques, and then talking about how to tune your prompts and even your large language model, and the best practices of prompting. And finally, we're going to delve into different methods, three different methods for fine tuning a large language model, comparing them using pros and cons. And that's it. First of all, let's talk about what does LLM do. You know, large language models have been pre-trained on massive large textual data, or in other related cases. So for example, consider vision language model, which are pre-trained on the combination of textual and visual data. But in this case, a large language model actually is a next token predictor. Given a sequence of tokens, and it uses its tokenizers to tokenize and identify tokens in a given sequence, in a given text, and then using this tokenizer to transform these tokens into a numerical representation which the model can understand. These tokens, these IDs, and it's a process of position embedding. It's a combination of position embedding for each token, identifying the relative position of each token, and encoding each of these tokens, and then we're gonna this will lead to a final embedding, which the model understand, and it starts its processing through multiple transformer blocks, and finally it makes a prediction. So for its prediction, it usually takes a maximum likelihood. What's the most next probable token given some precedent tokens? As you can see, in this case, the cat set on the is a given sequence, and the model predicts the most likely next word is math, or it can be rock or something like that. So these models initially, these foundational models, identify the next most probable tokens given a sequence of sentences. But if we want to make them to interact with user, we're gonna need some make changes to their training to actually convert them from base model to instruct model. The model can interact and make a question answering process, with users. And this actually, the model I find the most next probable token using the softmax function to find to which actually makes the summation of all tokens probability to one, and finding the and actually predict the next token that has the highest probability. So, but there are different methods for identifying the next tokens, and we're going to talk about this later. But as you know, LLMs are phenomenal for knowledge generation and reasoning. They can understand your sequence, different relationship between different text, and finding, because they use attention mechanism, attention, self attention, or cross attention between given a sequence, or identifying the relative attention between different tokens in a given sequence. They are promising there are promised the most powerful models for knowledge generation and reasoning. As you can see, there are some examples here which are generated by the LLMs, a general LLM. Some of them might be not true because they don't actually understand the meaning of them. As I talked about it in the previous slide, they are make a next token prediction. They are phenomenal at token prediction. So they don't understand each token's meaning in a given sequence. They have no sense of them. They just making next token generation to, as you can see, for different, and they can use for different tasks, for summarization, translation, and all of these are happening by this process, by this idea. But there is also multimodality. Some models have been pre-trained on the combination of vision, speech, language, and understand different types of queries. For example, a text, there might be a text, given text, or a signal, or vision, or even the combination of them, as you can see in vision language models that understand both text and vision in a relative manner, finding the mapping between each tokens of a sequence to different objects of an image, for example, in vision language models, and they follow a joint training process to understand the relationship between different objects of the image and the tokens of a text. As you can see, a prompt is describing this cat, and the model understand this and made a generation, as you can see here. Next, prompt actually, what is prompt? Prompt is the text that you feed to your model. So the model understands it and makes some computation under the hood to giving more to giving a reasonable response. As you can expect, it is generated by a human, but the more proficient the model, the more similar its response to a human. The prompting design are actually have prompting has different terminology. They have, for example, you can call it prompting, prompt engineering, priming, or in context learning. They're all similar and describing the same thing. And it's actually prompt engineering is the art and science of figuring out to what kind of text, your text should be curated to nudge the model to behave in a desired way, expecting it the best response, that is generated by a human expertise. Ideally, we expect response to be to be provided from an expert human in a desired way. So we need to ensure that our prompt, our text given to the model, is created thoughtfully, intellectually, and you can see here, prompt can include one or more of these following types. Question input is the question that is actually asked, is a question you have and you expect the model to answer it. And task is the problem that the model should deal with. And there are some entity input, so you give into the model as to guide it through this reasoning process, and the completion input for completing the sequence. But for context, you add some external knowledge. You add some description to the model to force it to reason within these area. And as you can see, there we have in this example, we have provided some examples for example, some key and values, just say here, JSON format, and you ask the model about these contexts. So the model first understand the context, then your question, and try to answer it given the based on our context. So it's grounding its uh, responses based on the given context you expecting it. This actually reduce models hallucination. So because they know in what area they should think about your problems. But after that, you have some examples you can see here. It's just similar. It doesn't need any explanation because it's easy. You can here read it. And we have three types of prompting. It's zero shot prompting, one shot, and few shot prompting. In zero shot prompting, you just ask the model you're providing the model with a single question without any external examples. But in one shot prompt, which seems to be more reasonable and expecting to have a better response in comparison with zero shot, since you actually teach the model to how to think about this problem, how to answer it. You actually give it some hint, you guide it through this reasoning process. But in such cases, the one-shot prompting might not be enough, and you need to add some external shot and giving some external examples, extra examples. As you can see here, this makes the model to process your question, make a better reasoning, and expecting a better and more consistent response with your expectation. But you should be aware of the context limit as you feed in more examples into the input, and there might be a little space left for asking questions, and the more larger the context window, the less the less probable to make the less probable that to your model that your model expecting generating more related response, more promising response. So you should be verify. It's a trade-off. You should find this trade-off by giving the optimal number of examples and expecting the optimal response. To expecting the optimal response. In this here, you can see we have temperature, top P, and top K. So temperature is actually showing the model to how to be creative. The more temperature is actually between the interval of 0 and 1. The higher the temperature, the more creative the model. The more creative is the model. So it's actually, if you want to know how temperature makes the model to be more creative, you should think about the last layer of these models. In the last layer, there's a decoder using by MLP. And after that, we have some logics. These logics are actually are divided by temperature. So if temperature goes up, this ratio goes down. So after applying the softmax activation function, the probability for all candidate tokens as the next token seems to be closer to each other. So the model by top P or top K selection criteria, the model it is they have this near same probability for selecting different tokens. So the model seems to be more creative. Otherwise, it's more consistent, more static, and it's if you want your if it depends on your use cases. If you want your model, you're working in a hybrid or dynamic environment, your model seems to be more creative and it should perform better. But otherwise, you should lower the temperature to expecting a more static, more predictable responses, more deterministic responses. Top here is actually selecting the number of tokens that their cumulative probability is uh, larger or equal than P. But in top K, you just only selecting the top most probable token as the next token. for generation, and temperature controls this creativity and this randomness. So, but you should be aware that temperature zero doesn't mean no hallucinations, since, as you know, hallucinations are responses that are generated not based on non-factual data. Uh, so it doesn't have anything with temperature. It doesn't have anything to do with temperature. In this slide, I have brought some example of generative AI on Vertex AI. It's actually telling us how Google or other giant companies work controlling the model responses, the input and output. When given a prompt, whether it should be zero shot, few shot, or multi-turn, it goes through a responsible AI and safety to identify there is no activity or malicious unwanted action that won't be happen but to user for malicious reasons. If the prompt is work is safe, it's forwarded to the foundation model, which can be a pre-trained model or a fine-tuned model, and then it goes through enterprise grounding service to find out whether it's consistent, it's comply with an enterprise regulations. If that's satisfied, it goes to citation to check to find if the sources are cited correctly and there is no leakage of data from these models to the users. As I said, some user might have different adversarial purposes, and these responsible AI and safety is actually responsible for identifying these activities and block them, reject them. If everything works well, the response provided to the user. But there are some advanced prompting techniques. As you can see, the first and the most important uh, of them is chain of thought. Chain of thought is actually a guide the model through some multiple intermediate reasoning steps. It guides the model to how to think. Is actually with a chain of thought, we aim to reduce the black box the black box intrinsic of model by giving it some hint to how to think step by step, but through intermediate reasoning steps. As you can see, in standard prompting, the model does not actually lead to the correct answer. While in comparison to the chain of thought prompting, the model thinks step by step to how to solve a problem by following our instructions, and it has led to the correct answer. As you can see, an example here, actually ask the model when you write a post to begin a topic and you should do the following. Start with a captivating question statement, highlights the importance of the topic, introduce personal answer or story that alludes to the positive impact the topic has had on your life. Share surprising, intriguing fact about the topic backed by scientific evidence, and so on. Then it's follow these instructions to actually solve the problem, to addressing a problem, given a question. This reduces model's hallucination since we know how the model think, and it has always led to the better answer and more desirable answer. It's promptly actually guide the model, it's promptly change the model behavior without any fine-tuning requirement, which is computationally expensive. As you can see, the generative response here, and the model has correctly followed our instructions. But there are some augmentation. There are some plugins for this chain of thought. Chain of thought with self consistency, which is similar to chain of thought, but think about it as uh, asking a model to generate to follow to repeating this chain of thought for multiple times and finding the most frequent response as the correct answer. For example, in this here, we have three different reasoning paths using chain of thought, but two of them has a result has led to the $18 per day as the final answer, but one of them um, provided $26 the final answer. We find out so by voting, by max voting, we find out that $18 that might be the correct answer. There are some pros and cons for this self-consistency. For advantages, it's easy performance boost. It doesn't need any training or something, computation, expensive computation or something like that. It's inspiration. It's inspired based on actually from it's inspired from your thinking, your the way of you think about the problem. It improves its robustness. It's more reliable, and since it think in different manners using the given chain of thought, the given instructions, but by generating multiple responses, you might be more confident about the final answer. And for its constraints, there are some costs as you need to generate multiple responses, which adds also some latency because the model must be run multiple times for generating response, and also it's resource intensive. It adds some computational complexity, and even you might be limited if you might be limited if you as if you repeat this process or use it um, in complex environment with multiple queries at a time, millions or thousands of query at a time. For the chain of thought, advantage is it's easy and effective, adaptable to different tasks. It doesn't need any fine tuning. It's managing this process promptly and changing the model behavior, changing the model's thinking way in a more quick way. And for React, it's actually similar to chain of thought, but it's a process, it's a loop, it's a loop of it's actually this React is an abbreviation of reasoning and acting. The model reason about the problem, taking some action. For example, it might be a tool calling and follow, and it's actually observe its response. It's evaluate how taking action has affected the environment. If it leads to the desired output, it's finished its thinking process. Otherwise, it goes to this loop again and again and again until uh, termination loop is satisfied or reaching to the correct answer. So it's beneficial. It is also used for complex tasks because it can also interact with external systems by thinking and taking action. As I said, it might be tool calling from external systems. So React is actually useful when you want your LLM to reason and take an action on external systems, and you expect to improve the accuracy of LLMs when answering questions. Explain here. And for retrieval augmented generation, it's also another type of advanced prompting techniques. It's useful when you're in hybrid systems, in a dynamic environment, when because large language models knowledge has been cut off, and they are not aware of about occurrences after the training, after the training point, training cut, training. cutting point. And using retrieval augmented generation is actually, as you can see here, there's a LLM retriever which uses external retrieval, which can be information retrieval system. Given a query, user query, the model finds out the related the context by asking the retrieval model to augmenting the related information. It can be uh, extracted from a knowledge database, knowledge graph, or any database which the model does not aware of its context. You augmented this context into the given query and provide it to the model. Um, this actually knowledge serves as a context, serves as a guidance for the reasoning process of the model, given the query, and the model generates its response, based on grounding on these provided context, which also reduces hallucination. Is also useful in different dynamic environment when you have a model with a limited knowledge about its surrounding, about its news or occurrences that happen after its training cut off. It's really useful and already used in many question answering system today. Before fine tuning a model, what you should be aware of using advanced prompting techniques, since they are by adding context and examples, or using chain of thoughts, because they are computationally efficient and it doesn't need any powerful resources to train your model with billions or millions of parameters. It actually promptly changes behavior. Um, Prompting best practices. In this step, I want to talk about some different tips that you can incorporate into process, expecting a better response if you follow these instructions. Um, One example is worth 100 instructions. You should be aware to always include example instead of adding different lines or multiple lines of paragraphs to describing the task. Giving one example, Giving an example is worth 100 times than the instructions. It can learn the model. It can teach the model to how to learn, how to think about the problem, and how to formulate the response. And this can be done using fusion examples and prompt. And the prompt is likely to be more effective. Reducing hallucination with DARE prompt. DARE is actually the abbreviation of determine appropriate response. Determine appropriate response means you should always set a model's vision, the mission, and adding the context, and finally asking the question or providing the prompt, so the model know how to think, know its role, what its task, what's the problem is actually need to be solved, and also using this context to actually solve that problem and providing the final answer. It seems to be more concise, more consistent, reliable, and that's it. Their prompt can be improved even further, especially for customer-facing application. Um, Actually, you can see here, there's an example. Your updated mission is to only answer question about elephant. What is your favorite elephant means? So I can change my name. You can see here, the model, actually the user has malicious purposes. It wants to, as it wants the model, it wants to it's tricking the model to reasoning wrong in a wrong manner. But with good prompt engineering techniques, you can reduce this problem and make your model more robust to these activities. modulate temperature for certain tasks. As I said before, in more dynamic environment, you should set the temperature into higher, expecting the model to be more creative. Otherwise, setting it to closer to zero for deterministic scenarios, generating the same response for the same queries, generating the same response. For the tips for use natural language for reasoning in chain of thought prompting. Natural language format is more favorable and in comparison with concise format, since users expect to talk about with a human, not like a robot or a language model, because and they expect a natural language reasoning, not a concise format or using abbreviation for its reasoning. Although it's really useful if you want to reduce its cost, for example, because chain of thought reasoning uses multiple intermediate reasoning steps, which produces extra tokens and leads to more latency and computational cost. But it's actually in a natural language format, which is more favorable to most of humans. Tips 5, pay attention to the order of the text in your prompt, which is really important, as I said before, for malicious activity. For malicious, if the user wants to trick the model, you can change the order of prompts to reduce this problem, to mitigate this problem, and make your model more robust. When working with tables, you can improve LM accuracy by describing every intent. As you can see here in the first prompt, the output result is actually it's less accurate in comparison with the new prompt, which seems to providing every details or more context about the table, different table rows, about the intent or about what actually the table is telling us. So the model expect to lead to better understanding of the table, about the different entities, about entries of the table, about its attributes, and eventually leading to better results. Consider a structured text instead of a wall of text, which leads to better providing, for example, providing JSON, providing a question to the model, providing the question with the model in a JSON format, instead of just adding context sequentially in different multiple paragraphs. Um, in here, it's in a more structured manner. The questions, the context, and rules are structured, are actually curated in a more structured way. So it's actually improves, it makes the model thinking neat and more more predictable. It doesn't actually confuse about how to reason if you're providing it with, if you're providing it with multiple different paragraphs or lines or documents that are sequentially placed after one after the other. Why fine-tuning include complete prompt training data? Because otherwise the model it doesn't know how to deal with the context or role of the model, because it has not seen these kinds of prompts in its training process, so it can not follow the instruction as you expect, and leads it actually mitigate reduce its performance results. Should be aware of that. Always remember responsibility and safety filters. As I said before, it's important to make sure that the user has not any malicious or unwanted purposes. It doesn't. No one. Your model doesn't. You don't want your model to be tricked or actually leaking some internal data about the company, about its regulation, to outside. So you need a filtering system to find input, malicious input, or unwanted actually responses to be forwarded to the users. You need to add in this system to ensure safety and responsible AI. And build your evaluation prompts using adversarial prompting techniques for improving the model robustness. For it actually let your model to know how to deal with different situations, with different concepts. It's improved the system because if and you need to add, you need to actually define evaluation method for rating your prompts, because otherwise you cannot actually improve your prompt. um, because actually you need to quantify the quality of your responses using these functions to improve your prompt and expecting a better results. It's always done using adversarial prompting for facing the model with different kinds of scenarios, finding how robust the model is, how robust the model is in different situations. You need to be specific about your prompt, avoid any open-ended or open-ended question that doesn't that the model doesn't know how to deal with this question. What the question actually is about. You need to have multiple prompt engineer working on the same prompt using different techniques, adding some contextual information as external info to guide the model through reasoning process, adding more examples to to help the model to formulate its response in a desirable manner, in a desired way. Try role prompting to stress testing or providing example to show patterns. Be careful with math and logic problems. Using fine tuning when appropriate, and but you need to be aware of using prompting techniques first because it's computationally more efficient. And you can actually limit the output length when using LLM because in some cases you don't always want the model to generate all multiple lines of unrelated responses to your question. You actually can eliminate stop its generation if you find out the generated response is already in a good format. It provides the response as expected. You can stop its generation to lead any additional cost to actually stop any additional cost or something like that. And finally, we are delving into fine-tuning large language models and customizing. Actually, fine-tuning is the task of further tuning a pre-trained foundational model, customizing a large language model. Because large language models have been pre-trained on different general contexts, they have a general knowledge, but in case of using a language model in a company in a actual private scenario, they are not aware of specific terminologies or about specific regulation, about specific private rules of a system. So you need to think about fine tuning a model on your data, your private data, which is not publicly available. The model has not seen yet before. Incorporating proprietary domain specific data into your models. So you can think about it as you can solve this problem by training a custom LLM, which is not feasible, as you can see here. It is not feasible by anyone because you have to train a large language model from scratch with billions or millions of parameters, which is really computationally expensive and requires high performing GPUs to run these models, and requires also immense resources actually and data sets to perform such tasks. But you can also tune a general purpose LLM, which means you're further tuning a foundational model which was previously pre-trained on massive data. This can be done by post-training or incorporating, emphasizing custom knowledge. These techniques are used actually in foundation models today already. As you can see in GPT-4, GPT-5 or something like that. These are called foundational model because they have been pre-trained on massive data by giant companies, and just following some further tuning, for example, for multiple small, a few epochs on your small data to actually change the behavior of a model, giving some insight about your private data. For example, for fine tuning your model, you can think about it. The first option is supervised fine tuning. Supervised fine tuning is actually providing the model with a data set of with actually paired data, which is incorporating a question and a response in a paired tuple in a tuple. So the model know for which question should generate which response. For each of question, you are providing the model, you are giving some insight to how to generate what's the perfect response is for each question. It's supervised fine tuning. So these responses act as a label in a supervised training. So if the model generates different responses for the given prompt, you actually penalize its parameter and penalize its parameter and updating its parameter to forcing the model to generate the desirable ground truth label. So the model tries to actually push it closer its prediction to the target output. But you should be aware of that it requires high quality data to improve the final performance. Otherwise, it will degrade the model performance. And also, there's another option which is reinforcement learning with human feedback, which involves training a reward function to act as a human rater, human grader, providing it multiple responses, and this reward function tries to sort them in a from highest to the lowest score based on to finding out which response is the most complete, the most concise, the most relevant response, is in high quality. Which one is the most high quality response? So this river function actually is trained by over human annotator data, because you want your model to respond as a human, just like you're talking to a human expertise, so you're giving it multiple examples, and using a reward function, you rank them from best to the worst response. And actually, the model learns which response is the most favorable and which one is not. There are also other techniques for fine tuning. If you don't want to follow the full training, updating all models parameters, which is really expensive and computationally complex, we've seen for reinforcement learning with human feedback or supervised fine tuning, trained updates all models parameters, which can be billions of parameters, which is time intensive and computation intensive. You can also, there are some alternatives. Expecting leads the near the best results, near the performance of full training. Uh, it's parameter efficient fine tuning, or PEFT as abbreviation. Um, by adding a module layer between different consecutive LLM blocks layers, so you just keep the model weights frozen while training these add additional module parameters. So the model give makes actually you are injecting some external knowledge by updating these module parameters, while uh, avoiding catastrophe forgetting, since you have frozen and rest of the model's parameters, so it doesn't forget what it has learned previously. And also you can use few shot in context learning. As I said before, it's a technique of prompt engineering, advanced prompting techniques, feeding a small number of training example as part of the input, but it actually because due to the context window limits, you might face a problem in how to ask your question or the final output accuracy. It's also computational intensive. Custom fine tuning with LoRa, low rank adaptation, low rank adaptation. Low rank adaptation is actually keep the, as I said before, keep the model weights frozen, but it actually decompose the matrix weights into low rank vectors. It's a multiplication of two low rank vectors, which leads to the same dimension of the weights. And you can see here for using LoRa technique, uh, the results is actually near the full parameter training as expected, and because it's actually keep the model weight frozen while adding some additional weights, but they're low rank actually, as it said, as you can see in its name, they're low rank, so it doesn't need to. So you actually don't need to update all models parameters, all models additional parameters. There are a small number of them, but it can lead to a better result without need to updating all model parameters, which is really time consuming. So, and finally, you can actually modify your prompts using different prompt engineering as we described it before. And how do LLMs have a conversation? For example, for now, most of LLMs actually does not have any, most of LLMs do not have any long-term memory. We're just trying to actually adding, augmenting previous conversation to its current prompt to giving it some sense of what was the history of the chat. And but some of them are now, some techniques are used by adding some decoupled modules alongside the main model, and there's a cache bank for expecting the model for each query, identifying the most related data from the cache bank using cross attention and also self attention. But most of them actually they don't have any long-term memory. Just inject some previously generated conversation, the question and answers generated by the same model, and augmenting them as the additional context to the current prompt, expecting them giving some sense of chat conversation, chat conversation history. So the model can lead to, so the model can generate responses based on previous conversation in the current question, but it might face input token limit as we are adding external, additional, actually long context. And also transformers don't change their mind. If they make a wrong prediction in the initial phase, this can accumulate to multiple layers and leads to unexpected or unfavorable response quality. And self-attention this in this scenario helps. More information in prompt leads to more specialized responses as this reduce their reliance to previous history, and they make reasoning based on the current context and current question. Thank you everyone for this presentation, for hearing this presentation. I hope you enjoy and learn something. If you need anything, if you have any question, you can ask me. You can contact me with through my email, which is provided in the link, and it's provided in the description below. And thank you so much.